we have discussed the bridge element, which is related to the Mendeleev table. In the Mendeleev table, if we have go in the second group, that is again divided into subgroup A and B. Then subgroup second A have the element is beryllium, magnesium, calcium, strontium, barium and radium. And we have zinc, cadmium, mercury. Now in this group, beryllium is in the second period and magnesium in the third period. So after third period, there are the two pairs of the element, means after third period Mg connected with calcium as well as zinc. So the Mg is called bridge element since Mg connected calcium and zinc. So in the Mendeleev periodic table, element which belongs to the third period is termed as bridge element. And in the bridge element, like Mg, its properties shows similarities with the alkaline earth metal, that is calcium, and the zinc metal, that is Zn. Another example of bridge element is phosphorus. It has joined with the arsenic and vanadium. So in the third period, elements are called bridge elements. Now after bridge elements, we have discussed about modern periodic table, that is called MPT, modern periodic table. In 1913, an English scientist, Moseley showed that the physical and chemical properties of the atoms of the elements are determined by their atomic number and not by their atomic mass. So, on the basis of Moseley experiment, the Mendeleev periodic law was modified and given the new periodic law, which was termed as modern periodic law. So we have discussed modern periodic law. Modern periodic law. According to modern periodic law, that is the MPT, physical and chemical properties of the elements are the periodic function of their atomic number, means physical property, that is pp, and chemical properties have the relation with their atomic number. Now we have discussed the another term that is related with the MPT, that is periodicity. The repetition of elements similar properties after a certain regular interval when the elements are arranged in order of increasing atomic number is called periodicity. And now, what is the causes or reason of periodicity? The periodic repetition of the properties of the elements is due to the similar outermost shell electronic configuration after certain regular interval. For example, if we have the example of alkali metals, in the alkali metals, that is lithium, sodium, potassium, rubidium, cesium and francium. The atomic number for lithium is 3, sodium is 11, potassium is 19, rubidium is 37, cesium is 55 and francium is 87. Now if we have write down the electronic configuration of lithium is, it has 1s2, 2s1, and the sodium, it has the 1s2, 2s2, 2p6 and 3s1. Now potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. And rubidium is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. And 4s2, 4p6 and 5s1. That is 6 to 8, 10, 12, 18, 28, 30 and 37. So, and in the cesium, the last cell becomes 6s1 and the francium, the last enter is the 7s1. So we have seen that in all elements, the outermost shell or outermost orbit have the general electronic configuration, that is ns1. Here is the n means number of principal quantum number. Principal quantum number means number of last orbit. In all element, in the last orbit, in all the element, a last orbit contain only one electron. Means the valency of all the element is 1. And we all know that chemical properties of the compounds depend upon their valence electron. Since all these elements have same number of valence electron, that is 1 electron, that's why chemical properties almost same of all the elements. And the second most important thing is that the certain regular of the repetition is that lithium and sodium, there is an interval or difference is the 8. Since 11 minus 3 we get 8. Similarly, the difference between sodium and potassium is 8. Here is the difference again 8. And the third is rubidium and potassium, the difference is 18. And next cesium to rubidium, the difference is 18. And the next is difference is 32. So here is the repetition of certain regular interval is that 8, 8, 18, 18 and 32. So we have said that on the modern periodic law, the element arranged in their increasing atomic mass number, then after a certain regular interval, that is 8, 8, 18, 18, 32, then properties of the elements are same, or after the fixed interval, that is 8, 8, 18, 18 and 32, elements are repeated which have almost same chemical properties.